All right, let's jump right in. We live in this super connected world where APIs are, the invisible engine behind pretty much everything we do online. But what if that very invisibility is their biggest weakness? What if your company's greatest security threat is the one you can't even see? So, for this deep dive into the shadows of our digital world, our main guide is the incredible book Secure APIs by Haro Peralta. We're going to break down some of the most critical ideas from it right here, right now. I really want you to think about that for a second. We spend a fortune on firewalls, on antivirus software, all the stuff we can see and point to. But the real weak spots? They're often hiding in the connections between our systems, the very things that are designed to be seamless and, invisible. And that leads us straight into what the experts are calling the API security blind spot. It's this huge, growing, and mostly unmonitored part of our digital lives. And you better believe that's where attackers are now focusing all their energy. Think about it. Every single time you check the weather, order some food, or log into a service with your Google account, there's an API making it happen in the background. They are literally the glue holding the modern internet together. But here's the catch. The more connections you create, the more doors and windows you're building, creating this massive attack surface that most organizations can't even fully see. This chaos leads to a problem called API sprawl. Now, this isn't a single bug, it's a state of being. Imagine trying to police a city where new roads are being built all the time, but nobody's making a map, putting up street signs, or even telling the police where they are. That's API sprawl. It creates this tangled, undocumented mess where all sorts of threats can hide in plain sight. And all this sprawl, it basically creates a digital haunted house. It's filled with the ghosts of old, forgotten code. And these ghosts have names. Experts call them shadow, zombie, and ghost APIs. So first up, you've got shadow APIs. Think of these as the secret passages. A developer needs a quick fix to get two systems talking. So they whip up a simple API, it works, and they move on. But they never write it down, and they definitely don't tell the security team. So now there's a backdoor in your system that nobody knows about, except maybe a very dedicated attacker. Then you've got the zombie APIs. These are literally the walking dead of your code base. You release version 2 of your API, it's shiny, new, and secure, but you completely forgot to shut down version 1. So that old, insecure version is still shambling around on your servers, just riddled with vulnerabilities that you patched ages ago in the new versions. And finally, we have ghost APIs. And honestly, these might be the creepiest of all, because they're the threats you didn't even create. You install a third-party tool, maybe a simple library to add a cool feature to your app, but you have no idea that comes with its own set of APIs. APIs you didn't build, don't control, and don't know are insecure. They're quite literally ghosts in your machine. This quote from a security executive just hits the nail on the head. It perfectly sums up the fear. It's not the front door you have 5 locks on that keeps you up at night. It's that one window in the basement you didn't even know was there. That's the real problem. So when an attacker finds one of these spooky, shadow, zombie, or ghost APIs, what do? Well, they look for a few common and absolutely devastating flaws in how they were built. Let's look at 2 of the biggest ones. First on the list, and probably the most common API vulnerability out there, is broken Object-Level Authorization, or BOLA for short. The idea is scary simple. What if your house key didn't just open your door, but it also opened your neighbor's door, and their neighbor's door, and every other door on the block? So here's how it works. The API checks that you're a valid user, sure, but it completely fails to check if you're the owner of the data you're asking for. The fix requires a total mind shift. You have to stop asking, is this a valid user, and start asking, does this specific user have permission to see this specific piece of data? Without that second check, a hacker just logs into their own account, asks for order number 123, and then just changes the number to 124 in the request to get someone else's info. And this isn't some abstract theory. This exact flaw in the Bumble dating apps API let a researcher pull down the personal information of its entire user base. Scary stuff. Next up, we've got a flaw that takes advantage of an API's trust. It's called mass assignment. This happens when an API is built to accept a big chunk of data, and it just blindly trusts and updates everything the user sends over, including fields they should never ever be allowed to change, like whether they're an admin or not. And this story is an absolute legend in the security world. Back in 2012, a researcher found a mass assignment flaw in the Ruby on Rails framework. To prove just how dangerous it was, he used that exact flaw on GitHub itself to give his own account permission to push code to the main Ruby on Rails project.
He literally hacked one of the most important open source projects on the planet just to get everyone to pay attention. The lesson? Never blindly trust the data coming in. You have to tell your API exactly which fields a user is allowed to update.
Okay, enough with the scary stories. Let's talk about how we actually fix this. Defending against these invisible threats means we have to completely change our approach. It's a philosophy called shift-left security.
So the old way of doing things was bolt-on security. You'd build the whole application, and then right at the very end, you'd throw it over the wall to the security team and say, hey, try to break this. But by then, it's too late. The flaws are already baked into the foundation. Shift left means moving security all the way to the beginning of the timeline. You don't just test for security at the end, you design for security from day one. So what does shifting left actually look like in the real world? Well, it all comes down to a few fundamental principles that can be the bedrock of your API defense.
First, and this one is huge, get it out of your head that there's such a thing as an internal API. In today's world, you have to treat every single API as if it's open to the entire internet. Second, validate everything. Never, and I mean never, trust user input. Define exactly what data you expect to get and reject anything that doesn't fit. Third, document your APIs. The only cure for API sprawl is having a central map, a catalog. You can't protect what you don't know you have. And finally, use role-based access control, or RBAC. This means creating specific roles like admin or viewer and making sure they can only access what their role allows. It's like giving people a key that only opens the specific doors they're supposed to go through. You know, we tend to think of our website as having one main front door, but a modern app has hundreds, sometimes thousands, of API endpoints. Each one of them is a front door. So the question we all need to be asking ourselves is pretty simple. Have you actually checked all the locks?
If this helps you see the invisible connections that power our digital world a little more clearly, then clicking like and subscribe is a massive help for us. It lets us keep making more explainers just like this one for you. Thanks for watching.